Yeah, it's been shared. That it's been shared. Thank you. Yeah, thank you, Tanya, for sharing it. And yeah, I see more people joining. So I think we can move on to what we're going to talk about on this particular session. Okay. All right. So we're going to be talking about the omni-processor project, which is it's being implemented in Bangladesh, in Cox's Bazar to be more precise. We have quite a few presentations. We usually don't do this, but this is such an interesting this is such an interesting topic that we are going to start with our colleague from the Bangladesh Resident Mission, Sharjah, and then Mr. Jignesh Shah. He's from Anchor Scientific, and he'll be talking about the technicalities of this project. We'll have a short Q&A, and then we're going to move on to Mr. Mohammed Muqtadir, who's the project director from the Public Health Engineering in Bangladesh. Then bit of a shorter Q&A. So, you know, if you have first questions to Mr. Jignesh, shoot it, and we have about 5 minutes to go to the more fervent ones, and then we have a solid 25 minutes for everything else. And then our colleague Christian is gonna wrap us up. I'm your moderator. I'm Mafalda. Sorry, I forgot to introduce myself. Yeah, I'm gonna now hand it over to Ms. Sharjah Sultana. Please, Sharjah, can you share your screen and tell us more about the omni-processor? Thank you.
So Mafalda, is it okay?
Yeah, it's perfect. Yes. Now it's perfect. Great. Go ahead. Thank you.
Thank you, Mafalda, and thank you all. Good afternoon, everyone from Bangladesh. Thank you, ADB Circular Economy Working Group, for inviting us in this webinar. I'm Shazia, Project Officer of Emergency Assistance Project. The project was initiated to support the government of Bangladesh in addressing the immediate and urgent needs of the displaced persons from Myanmar in Cox's Bazar district after Cox's Bazar district in 2017. So after signing the grant, 100 million with the government of Bangladesh, the 4 years duration project got started in October 2018. EAP Emergency Assistance Project is a multi-sectoral project focusing on the improvement of water supply and sanitation, disaster risk management, sustainable energy supply, and access roads improvement. This project is being executed by Public Health Engineering, Local Government Engineering Department, Roads and Highways Department, and Bangladesh Rural Electrification Board. The project is being implemented in coordination with the UN agencies, the World Bank, and other humanitarian donors. The support under the project is within the framework of multi-sector joint response plan prepared by the UN-led Inter-Sector Coordination Group in coordination with the government to support the FDMS for the nationals, including the host communities in Cox's Bazar district. Before going to omni-processor, I'm just giving you a short brief of the project because omni-processor is one of the part of this project. So one of the key issues which was not initially addressed in the project because this is an emergency project. So this issue was related to waste. During implementation, it was identified that existing waste treatment plant requires large areas and can treat only the fecal sludge. Even further treatment and land is required for sludge and wastewater. Unfortunately, laboratory analysis, which was done by DPHE of wastewater from existing plants, were not meeting Bangladesh national standard, environmental standard. In a camp situation, which the Emergency Assistance Project is addressing, these constraints of space requirement, multi-type waste treatment and disposal, and complying with national environmental standards needed an innovative waste management solution. So we came up an integrated fecal sludge and segregated solid waste treatment plant at Camp 4 Extension as a pilot intervention. This integrated waste facility is being required only 1,000 square meter land for the plant and can serve minimum 100,000 population within the camps. Omni-processor is a community scale-up fecal sludge and solid waste processing unit that generates distilled water. That is the output of this omni-processor. Not only distilled water, also generates electricity and biochar from the this biochar. All of these outputs have notable to be used in other development interventions, for example, biochar for agriculture production. This will also help to comply with Bangladesh National Environmental Standard on solid waste and effluent. Based on the potential of omni-processor in emergency assistance project, we have a plan to scale up this approach in the second phase of the EAP, which has just started in 2022. The construction of the plant is completed, and installation of the boiler and other parts are ongoing and at the commissioning stage. So we are anticipating that this omni-processor plant will be in operation by December 2022. Here are some photos that the left one, these photos. This is the gasifier of this plant that is almost complete. Here are the people segregating the waste, solid waste in different, for example, that plastic, some other organic waste. This is the truck that is already procured under this project, and this is another facility under this project. So we are expecting that our contractor will open this, complete this work by December, and we can open it. So thank you all. Thank you. Thank you so much. Mafalda, over to you.
Great, thank you so much, Shaja. Really cool to see the setting of this project. All right, so Mr. Jignesh, could you walk us through the technicalities of this project? Thank you. Please feel free to share your screen. We still don't see this the screen share. Oh, here we go. It's starting. Thank you. All right. Yeah, we're on. Thank you. Go ahead, Mr. Jignesh.
Yeah, good afternoon, everybody. My name is Jignesh Shah, and I am from Ankur Science. So a formal welcome to all on the omni-processor slideshow. I would like to start with what the activities we are doing and what about our company. So this company was founded in India in 1986 by Dr. B.C. Jain, who is a chairman of this company. So we are almost 35 years old company, having more than 1,000 installations in 47 countries. And we are also ISO 9001, 14001, TUV, 14,001 certified company. So our main products are the gasifiers. So when I differentiate between the gasification, pyrolysis, and combustion, so in a layman language, if we provide a stoichiometric air to any hydrocarbon or waste, it's known as a combustion. But if we do not provide any air, that is known as a pyrolysis. But if we provide a partial air, it is known as a gasification. So what the gasifier does, it converts the any waste, whether it is a solid waste or biomass, into a combustible gas. It makes the CO, not the CO2, and this gas travels to the furnace for further process. So this is the concept behind the gasification. Gasifier where solid waste and biomass is fed from the top. Initially, the charcoal are burnt on the grate. As we burn the charcoal, the temperature will rise. You will find a maximum temperature on this area, and as you go up, the temperature will be down. Now the solid waste and biomass is fed from the top. The moment they come into the contact range of 100 degrees centigrade, all the moistures in the solid waste starts to evaporate. It gets converted to the water vapor. As the waste moves down, it comes into the contact range of 400 degrees centigrade, which is a pyrolysis zone. Pyrolysis is nothing but a decomposition of the waste. So the waste are getting decomposed to the various vapors or various gases. So the water vapor and various volatile matter gases that we generated from the pyrolysis zone travels to the high temperature combustion zone, where some of the CO is converted to CO2, which gives the energy for all the process, and the excess CO2 that will pass on the charcoal bed, which will get reduced again to the CO. And then we take the gas from the downside of the gasifier, which is a mixture of carbon monoxide, hydrogen, and methane, and it is known as a producer gas. So we generally know the natural gas, which is a methane. We know the LPG, which is a propane. So this is also a one kind of gas, which is a combination of carbon monoxide, hydrogen, and methane that we have generated from the municipal solid waste or bio waste. Once we generate the gas from the gasifier, the left out portion is the biochar, which is used as a fertilizer. So this is a schematic of the gasifier. You can see the gasifier main reactor. The gas is getting generated, the gas is pulled, and it is then sent to the furnace for the further process. And the biochar, the residue that automatically comes out, we can use as a fertilizer. So the gasifier is our main products, and in 2017 we tied up with the Bill and Melinda Gates Foundation, and we have been appointed as a commercial and technological licensee to develop the omni-processor. So omni-processor is a brand name of the online fecal sludge treatment plant, and as I said, we have commercial licenses. The main feature of the omni-processor is that once the sludge enters to a FSTP, there is no manual process till there is a sludge reduction volume of 97%. In this technology, we treat the sludge as per the EPA guidelines, and we generate the byproducts like energy, distilled water, and industrial grade water. And the energy that we generate from this omni-processor is fed to run all the plants. So the system is known as the energy neutral. We do not require power from the grid or any other sources to run the plant. We do not require water to run the plant. We do not require any manual labor job. So this is the benefits of the omni-processors. This is a three-dimensional drawing of the omni-processor, where we have mentioned the stages of the various process. So once the vacuum truck comes with the sludge, if the sludge is discharged in a sludge volume tank A. Now this tank is with a agitation. The reason why we agitate the sludge, because we do not want any solid particles to settle, and we want a homogeneous mixture. So once it is agitated in this tank, it is pumped to the volute screw press. Now volute screw press is nothing but is a solid water separator. So free water gets separated, and the solid, which is conveyed from inlet to outlet with a narrowing pitch of the screw conveyor, which acts as a squeezing of the solid. just like a sponge. So any further water is trapped between the particles, it is also removed, and the sludge is delivered to this belt. The water that gets separated goes to the MBBR treatment and collected as an industrial grade water. So if I go on fact and figure, if we have a COD say 40,000 milligram per liter in a sludge and BOD around 20,000 milligram per liter, the water that gets separated in the bolus slough phase has a 700 milligram per liter COD and BOD. That is a 97% reduction. So we designed this MBBR to take a load of around 1000 milligram per liter, and outlet water that we collect has a BOD less than 10, COD less than 20, which is good for the industry, for river discharge or for any industrial purpose reuse or for irrigation. So this is a one source of the output of the industrial grade water. The sludge that we have collected in the outlet of the volute slough press goes to the dryer, and in drying process, there is a 10% moisture and 90% solid we get during the drying process. This dryer is working on the boiling process, boiling principle. That means dryer is operating at 100 degrees centigrade, and as per the EPA guideline, if you boil the sludge minimum at 70 degrees centigrade for 30 minutes, you can be ensured that there will be a no pathogen. Here the process takes place more than 70 degrees centigrade and detention time more than 30 minutes. So we treat the sludge as per the EPA guidelines and reduce the moisture to a 10%. While we are reducing the moisture, there is a water vapor that goes to the condenser, So water vapor gets condensed and converted to the hot liquid, which is subcooled to a normal atmospheric temperature, which is again going to a tertiary treatment of pressure sand filter, activated carbon filter, UV, RO, ozonations, and we collect as a distilled water. So distilled water is not good for drinking because it doesn't have a mineral, and if we drink, it can take minerals from our body. So as a last stage, we add the minerals to the distilled water and gets converted to the drinking quality of water. So this is the second output, that is a distilled water. The biosolids we get from the dryer goes to the boiler where we generate the high pressure steam, runs the turbine, and we generate the power. This is the third output, and the power generator is fed to entire system for running the plant. This is the back pressure turbine, and exhaust steam goes to dryer again for providing heat for the boiling. So this is a closed circuit and whole process is automatic. So once the sludge enters in sludge tank A, there is no manual job. All the sludge is treated as per the EPA guidelines with a 3 output: industrial grade water, distilled grade water, and power.
Mr. Jignesh, sorry, thank you.
Yeah.
We're running out of time on the right now. So could you wrap it up in the next 30 seconds?
Yeah, sure. So this is the benefit of omni-processor we already discussed. And this is the integration of solid waste and liquid sludge. So if we integrate the gasifier, solid waste, with the liquid sludge, we can have a excess energy. So liquid sludge is only for the energy neutrality, and for excess energy, we can integrate solid waste also through the gasification to the omni-processor. Thank you. So if we have a time, we can then run the video. Otherwise, we can send the link to everybody.
Yeah, maybe let's see how we get on with the Q&A. I think for now, we'll move on. And I don't know if there's any questions. Okay, we have one question from Mr. Milind. Yeah, and the question is, why is this method not popular in India?
Yeah, the reason is that this technology was developed by Sadron, one Seattle-based company under a grant of Bill and Melinda Gates Foundation in 2016, and I went to Seattle in 2017. We took this challenging job, and in 2019 we installed this first project in Vadodara, and after that there was a COVID. So we do not have sufficient time for the commercialization of the product. But now, yes, we are in the market and a lot of inquiries are coming and people are coming to our plant to see the performance. So I think the system will be popular soon.
Okay, great. And Mr. Jignesh, could you just give us a bit of like a context of why this technology, what are its benefits to the communities in Cox's Bazar? Just briefly.
Yeah. So first of all, the space that required for such type of technology is only the 15% of the space that required by the biological process. And second thing, in the biological process, you are not treating the sludge. You are treating only the water. So the main criteria of treating the sludge is fulfilled by the omni-processor, where you treat the sludge as per the EPA guidelines, and there is a no manual job also, and we are getting an output also. So the operator need to sit on the control panel and whole process is automatic. So once is the space, then the treatment as per the EPA guidelines, and 3 outputs are the main reason why this technology is beneficial.
Thank you. I think we have time for one more question on this slot, and we have again from Mr. Milind. Do you want to come up on microphone and ask it? Okay, I'll just read it. So Mr. Milind's question is, what about the cost compared to other methods? You talked about the size, and how about the cost?
So if I compare the cost, including the land cost, then yes, omni-processor is cheaper. But if you are not considering the land cost and you are comparing only equipment cost, then omni-processor is having a higher capex than biological treatment.
Is any patent cost involved in here, because the technology is developed in Seattle?
Yeah, so no patent cost is involved because this is patented by Bill and Melinda Gates Foundation, and during the first stage of development, they also provide a grant to us. So I don't think that there is any patent cost involved.
I think in Maharashtra there is a place called Y. So this plant is present there.
So why is a different technology? It is known as a pyrolysis, where the drying takes place at 55 degrees centigrade. So drying can take place at any temperature, but when you are drying at 100 degrees centigrade, it is known as a boiling. So boiling is a different process. So why is it totally different technology, which is a pyrolysis with a drying on the 55 degrees centigrade, which doesn't meet the EPA guideline.
Okay, thank you.
Yeah.
Okay, thank you so much, Mr. Jignesh. All right, let's move on to our next speaker, who is Mr. Muqtadir, the project director from the Bangladesh side. So yes, could you please share your screen? It's showing.
Yes.
Okay, here we go. Thank you.
Muqtadir here from Bangladesh, and project director for the AP project. So topics is like circular economic solution in solid waste and liquid sludge management. I think I am the least person who knows about this thing. I am very new to the urban sector, but I will try to elaborate the situation. As you can see here, that the government of Bangladesh is very much committed actually to move on to this circular economy. And related to that, we have already approved many strategies. And you can see that national strategy, and also 3R strategy for waste management, and national strategy for water supply and sanitation, solid waste management rule, and intended national determined, controlled. And in the 8th five-year plan, in the development of the subcontinent also, it's only in Bangladesh, it's a 5-year basis. So this is the 8th five-year plan currently going on. And that also highlight the circular economy. That is basically 3-year strategy following. So Bangladesh government is very much committed to implement the circular economy in the sector, waste management, and related rules. So it's already the policies there, and as well as the institutional framework is also there. In 2017, fecal sludge, IRF has been approved. So the institutional framework is also there. So if we move on to, sorry. Okay, so now what's the difference? So as I mentioned, 2017, when the IRF introduced and approved, earlier we used to do this linear system, very simple one, mixed waste, informal bin system, incomplete collection and burning disposal to the end, and after all this, it's impacting the environment. And open and uncontrolled disposal that produced an ad hoc maintenance of the disposal. But after that, we introduced the integrated waste management system, which we are now recently doing. And I think here I should give the credit to the ADB, that the ADB focus supported project with the DPHE, introduced the fecal sludge management initially through the department, and we installed secondary town project. There were 16 secondary town project, and there actually we installed, I think I remember 11 town had fecal sludge management system. So from that we started, and now we have other example in the country. So this integrated waste management approach, and we can have example of Shokipur, which I was also a very proud member. I used to work with the WaterAid. They are actually in 2014 to 15, we introduced this integrated waste management, an example there in that municipalities, separation of waste, formal bin system, and the whole system, and considering the whole municipality, that means the citywide thing. So there actually we introduced the citywide approach and initiated, and now all the project implemented by the Department of Public Health Engineering is now following the integrated waste management system. Yeah, and then actually in 2020, DPHE established, LGD established Switch FSM support cell in DPHE to coordinate, collaborate, and advocate this integrated system, and following the citywide inclusive sanitation approach, that is SWICE FSM approach. So this is the pioneer that we are now leading the sector, trying to coordinate between the agencies and collaborating and advocating. So working with FSM cell is very well connected with all the sector partners, and you can see our running project is like 23 towns with support from ASDB, and 32 towns project is supported by government itself, wholly solely government, and the 30 towns ADB, and there are.
Mr. Muqtadir, we're losing you for a bit. I think your connection is a bit patchy.
Oh.
Okay. I don't know.
Is it okay now?
Yeah,
now
I think
okay.
so. If it starts, if it continues, maybe I'd ask you to just switch off your camera for a little bit. That might help. Hello? Okay. Hello, Mr. Muqtadir. Oh, all right. Okay, we lost him. Oh no. All right, it happens. Oh, I think he's back. Mr. Muqtadir, you're on mute.
Now it's okay. Can you hear me?
Okay, yeah, we can hear you. What I might do from my end, I think I can switch off your video because I think you might be having some bandwidth problems. So I think I might, and that might help you, might help us hear you better. Okay.
Yeah.
All right, I'll do that. Thank you. And can you just reshare your presentation? We're not it stopped here from our end.
Yeah, I think we have enough time. I just continue and finish and then.
Yeah, I think you still have a couple of minutes. So yeah, if you could, I think you could go on for like 2 or 3 more minutes and then.
Okay, so what I just mentioned, so Switch FSM support, we have a future project projection, more than 100 town projects supported by different development partners, AIIB, ADB, ISDB, AFD, GOB, and about $1.5 billion USD project is up in the pipeline. So then the project.
Mr. Muqtadir, we don't see your slides.
Yeah, I think I already unshared as you mentioned.
No, I was saying your camera, but no, your could you then do we share your screen?
Sorry, I thought.
No, you're okay. Don't worry. Your connection is a lot better now. Thank you.
Now you can see it.
We see it. Yeah. Can you just put it on? There we go. Perfect. Thank you.
Okay, from here we had this one, and you can see the monitoring dashboard was introduced by the FSM cell, and technical solution is provided. Innovation technologies, different innovative technologies like what we just heard, we are trying to implement, and capacity development and quality assurance. I think I already covered right side part. Then these are the progress, how we are planning to cover the whole country with support from different projects and development partners. Then I think we have, you can see that DPH and ADB have based on this 3R technology in this project on the Cox's Bazar, what we are doing in this my emergency assistant project. I think Shazia already covered most of it. So what we did earlier and what we are doing. So I think she covered mostly. And this is some example what we are doing there. We have total population, household, and this type of technologies, decentralized approach, compost bin, drying, maturing sheds. So the costing is also there. So in 2020 we implemented, and these are some pictures what we did in the camps. You can see it. I think thank you from my end. I think I'm within time. Right? Thank you very much.
You're perfectly on time. Thank you so much. All right. So we're on to our Q&A. Again, to the people joining us on the call, feel free to drop them in the chat. We have here 1, 2, actually is to Shaja. And is there a plan to scale up the solution to the rest of the camps in Cox's Bazar?
Yes, actually, I have mentioned in my presentation that the second phase, that is the additional financing of emergency assistance project, just started. This project was signed in June, end of June, and the project become effective in August 2022. So this project period is 2 years. So we have a plan. We have planned for the Cox's Bazar host community, because earlier the pilot is for the host, the FDMLs. This time we are planning to have this one for the host community, for the district level. Yes.
Great. Thank you. Thank you. And I also saw from Mr. Muqtadir's presentation that there's other plans besides there's other initiatives going on in the circular economy that go beyond the omni-processor. Is that right?
Sorry, I didn't get it.
So I was just asking, on your last slides, you were showing some other initiatives that are not only the omni-processor for the rest of the country. You were sharing about composting, right?
Yeah, we have the fecal sludge FSM cell to actually select the different options. So this is the one of the options Omni we're talking about. So after piloting will be, like after the evaluation, after the only then we can say like this. So there will be many different innovative technologies that would be piloting throughout the country.
Thank you. Thank you. We have a question from the chat from Mr. Joel. And it is the Omni technology used by other countries? And I guess this could go to Mr. Jignesh.
Yeah, so sorry, what is the question?
So the question is the Omni technology used by other countries?
Yeah, so as I said in my presentation, the first pilot project is in India and the second is in Dhaka, Bangladesh. But yes, we have now a lot of inquiries from the African countries, then European countries, then UK also. So as it is on primary stage, we are expecting this omni-processor to be replicated to many countries.
Okay, great. I have a question to Shaja, and that is, so we understand that the community then started to use more to segregate their waste. And how was that process? Was it hard, or what sort of interventions did you use to get them to segregate the waste?
Segregate, actually the typical technologies in the camps, there are a number of technologies they are currently used. If I give you a data, in that case, units probably around 200. And these are very conventional, for example, anaerobic or constructed wetland. So we are in our technology, in omni-processor, we have solid waste, also fecal sludge, also plastic waste as well. So in the sludge, solid waste, this is segregated and keep in different way, different facilities are there to preserve. And I would like to introduce Iftekhar Bhai, actually, who is our main focal for this facility and who can actually help us to give you a brief on the whole technology, even the whole process of the Omni. So Iftekhar Bhai, could you please add on this?
Okay, thank you, Sadia, and good afternoon to everyone. Just to give you a quick background about the project. So when this project was initiated, what we have found is that there was a challenge with the solid waste management. So there were several FSTPs, small around 200 FSTPs serving probably 800,000 population, and the land footprint was too high. It was around 37,000 square meter was required to have this small units. And then what ADB and DPHE thought that why don't we have a solution where we can minimize the land footprint by having a technology which can treat both the solid waste, organic part of the waste, which can also have the fecal sludge as the input, and also plastic waste. In the camps, what we have found that there has been a source separation being promoted by the several NGOs working in the camp. But the problem, what we have found is that even after source segregation of the waste, there were issues with the single-use multi-layer plastic. So, and that was the time we thought that in the treatment technology, which Ankur is installing in the camp, it has three types of waste stream. It has the organic waste segregated, and then it has also fecal sludge and single-use plastic as our feedstock. Now, in the organic waste management, usually there in the camp, they were doing informal landfilling, and there were cases of and if you dump the waste anaerobically in an open dump site, there is the potential of methane emission. So we had to cut it down. So when you are diverting waste from landfill to Omni, so that methane emission is avoided. And if you look into the landfill, conventional landfill, to dispose 1 ton of waste, you require at least 1 cubic meter of space. So considering all these things, we promoted and we thought that Omni is the best solution. Regarding the question how we have promoted the source separation, it was the NGOs who are involved in the waste collection. They have been trained and they have been promoted to provide 2 bin system for actually 3 bin system for segregation of the waste, and then and all the recyclables which are like which has an easy value like PET bottles and tin cans and paper, it is sent to the recycling industry, but the single-use plastic is used as a feedstock for the omni-processor. So and this is where I would like to highlight one more point, that in the 8th 5-year plan, the government of Bangladesh has clearly focused that waste, any technology that should be used must have a low land and carbon footprint. So that Omni, what we have found is a technology where all these criteria can be met. So that is the reason ADB and DPHE, they are piloting the first project in Cox's Bazar, and after operation, and once we have the data, it would be quite useful to decide for the scaling of waste. So if you have any further question, I would be happy to join later on. At the moment, I would like to stop here. Thank you.
Thank you, Mr. Takar. Thank you so much. Thank you for joining this discussion. I also wanted to present Marjana Chaudhary. She's the water resources specialist from Bangladesh Resident Mission, and she's also been involved in this project. I have a question, Marjana. So, and this is bringing it back more to the circular economy side of things. We've heard that the omni-processor transforms solid waste and the fecal sludge into energy, distilled water, and ash that can be used for agriculture. I know that the plant is not operating yet, but has there been a study to assess how will be the acceptability of this ash by the farmers?
Thank you, Mafalda, and good afternoon, everyone. So as Shaziapa mentioned, that this project has started in 2018, just after the influx of the FDNS. So during the design phase or during the inception phase, this component was not there initially. But later, when we had the midterm review, the mission or the experts has realized that there are solid management issues. So after that, we started building up something that can address this issue, the solid waste management, the fecal sludge management, and the municipal waste. So after that, it took us quite some time because it's a very new technology. In fact, as Jignesh mentioned, it's only the second one in South Asia. The first one was done in India, but the one in Bangladesh is a more, I would say, a customized, more value added to the initial design. So it's completely new for us as well. And as Iftikhar mentioned, it's a pilot for us. So we are still not sure how it will function. We are looking forward that it runs well, and because there are many factors, because it's inside the camp. And if you may know that this is one of the biggest camp in the world. So there are many agencies working, all you name any UN agencies and any organizations working in this waste management, they are there in the camp. So good number of coordination is required to properly function and make this facility a success. So we are working on that. And about the study, the feasibility, we haven't conducted any study yet, but we plan to do some during 2023 because the project has, we started the additional financing of the project. So during that additional financing phase, we will do an evaluation kind of study, and at the same time we will capture what we have done, because it was a very I mean, it was a learning experience for ADB as well. Here I would like to just include that it took more than 1 year to prepare the bidding documents because everything was new. Iftekhar Bhai has supported ADB from scratch. So it's the whole thing. I should say that we have process documentation which will support other South Asian countries to implement such projects. So yes, next year we hope to do some kind of lesson learning a study or a feasibility study on this project.
Great, Mariana, thank you. That actually links into one of the questions that we just got here in the chat. So will ADB produce a knowledge project about this this project? Great.
Yes, we plan to produce a knowledge product not for specifically Omni, rather for the entire project, because it's a multi-sector project, it's an emergency project, it's quite new to ADB, especially in Bangladesh. So we will produce a knowledge product, what went well, what are the good things that have been done, because in this project, this is one of the innovations. We have other innovations in the energy sectors, we have other innovations in the disaster management sector. So we do have quite a number of innovations in this project, and we plan to do knowledge products sometime next year, which will help other ADB countries to implement such initiatives.
Great, thank you so much. Mr. Muqtadir, so just as there's so much that is being reused from this plant, you mentioned some quality standards and policies on these outputs. Can you just talk to us a bit more about them? What are they all in place now? Will there need to be some more developed in terms of, like, I'm thinking about, for instance, the ash and the quality that it has for agriculture?
Yes, great. Yeah, this is also one of the area that there is not only the policy. Policy is already, I think, very well established and in place. But what you mentioned here, like, this is a real challenge, that how you use the end product without completing, if you like, the quality you just mentioned. The product is who is going to certify the product, and the certification of this, like fertilizer or the ash you just mentioned, like these. So these challenges will be also, I think, we need to identify, or we have some institutes that can handle this type of things, because these need to be environmental agencies. We have DOE, Department of Environments. They can also certify the fertilizer, because when there is the involvement of the fecal sludge, sometimes the output is people are reluctant to use, or whether if this is safe or not. So this type of issue come up. So if we can certify that these are safe, and so these proceedings is also going on. Like I just mentioned, Shokipur. So there also the fertilizer is there, and the huge demand is in the field. So they are completing the economic cycle, but the certification due to some policy or some decision making, we are not getting that type of thing, because it's not clear.
Okay, Muqtadir bhai, can I add here?
Yeah.
Yes. Okay, thank you. For organic waste, for compost, there is a standard of Government of Bangladesh which has all the parameters mentioned. So this standard was approved back in 2008 for organic fertilizer from household sources. So if you are not using the fecal sludge, if it is only the household waste, there is a standard available, and that is mandatory. If you comply with the standards, you are able to commercially market it. Now the question comes also for the second issue, that what about the ash? So if you look into the design of our omni-processor site, there is a compost plant what we have also built. The reason is that when you are having this biochar or ash, we would like to have a combination of it with the compost, so that it has a high market value. because the government rule is saying that it has to comply with the ash has to be somehow mixed with the compost before it is marketed. So that is the reason in the design we have incorporated a small compost plant, so that about 3 tons capacity, so that the ash can be reused and mixed with the compost and sold to comply with the government of Bangladesh standards. Now there is also one more standard which was I think declared by the government. It is called the Sludge Management Guideline. It has a standard for domestic sludge, and when we prepared the bid document for the Omni project, we have asked Ankur Technology to look into the standard, and they have to comply with it. So the compliance thing is that they have to comply with the air quality standard of Bangladesh. We have an air quality standard, because when you are running an Omni processor, there has to be some stack emission test. So that guideline is available in Bangladesh, the air quality standard. We have the standard for the compost or reuse of ash as fertilizer is a standard. And then I am also telling you that the last standard is also on the water quality. So whatever is the water coming out from the plant, it has to comply with the environment conservation rules. We have a water quality standard for discharge into the public drain or water bodies or natural drainage canal. So standards are there. Now, once the project is operational, we would do a kind of a monitoring to see that whether the compliance is there. But in the bid document, when we prepared the bid, this compliance issue was mandatory, that the technology provider has to comply with all these standards. Okay, thank you. I hope I have answered your question, Mafta.
Yeah, no, thank you. We have one question on the chat, and it's about if there was a climate change impact assessment done for the project. I think that's more for you, Mr. Iftikar.
So we have also done a analysis that what could be the emission reduction from the project. Huh? So this analysis has been done. That in case this whatever waste we are bringing, if we use the conventional technology, it would have ended up in a landfill, and the sludge from the drying bed without Omni, it would have ended in an open landfill disposal site. So we have calculated the baseline emission, what could have been no project scenario, what could have been the emission. And once we do this project, we have also done that what is the emission reduction. So this mitigation angle, we have actually calculated, and what we have seen is that by having this project in Camp 4 extension, what is going to be the total emission reduction in the entire duration of the project. So that analysis is also being done, and it's available with us. And I hope Mardana Appa and my colleague Sadia Appa, if required, they can share the numbers with the team after the call, after the meeting. So this has been done. Thank you.
Great, thank you. I have one last question for Mr. Jignesh, and it is, if there was there a big difference, or was there any difference between designing this plant in Bangladesh versus how it was designed in India?
So there is some difference in design. In India, the size of the plant is 200 meter cube per day. That is the 200 KLD per day. And in Bangladesh, the size is 30 KLD per day. Now, the challenge to design the equipment for such a small volume is to find a equipment turbine which generates a power with the highest electrical efficiency. So we need to change the design of dryer. So in India, we are using a steam as a heating source. In Dhaka, in Bangladesh, we are using hot water as a heating source. So we are expanding steam more in the turbine. So that is only the difference.
Okay. All right. Thank you. It's very interesting. I think we could go on for quite some time, but we're reaching the end of our session. And so for that, I'd like to call my colleague, Christian Walder. He's an urban development specialist from the South Asian department. And so Christian, please.
Thank you very much, Mafalda, and thanks to all speakers for sharing your insights during this really interesting session, and also to all participants for the lively discussion and for raising your questions. I think this is very important. I have to say I've really enjoyed the last hour because I've learned a lot. You know, you were mentioning it's the second installation in South Asia, and I think we will closely monitor and closely follow the next steps and how this project will evolve and how this project will progress. In closing, I basically just want to highlight 3 important points that have been discussed also throughout the last hour. So first, the importance of innovation. We all know that we have to be more innovative in the water and in the sanitation sector, and we all know that standard solutions do not work. So I was very excited to hear, obviously, the Cox's Bazar situation is a very specific one, but obviously the omni-processor technology was the best solution in this respective environment, in the respective setting. And I think we really need to actively seek out to find the latest innovations that are available in the water sector when we develop and design our programs and projects. The second point I would like to make is I think PD has made the point on identifying the market for the reuse products. I think this is a crucial point that needs close follow-up. So we need to have a clear understanding about the market value of the products we want to recycle, because without having a market, obviously this has implications on the entire sustainability of the projects. And I would be keen to hear more during the next presentation how this is going once the plant is online. And the last point I would like to emphasize, and then I'll stop, is really focused on the sustainability and on the operation and maintenance of the technology. I think it has been raised by a colleague in the chat box. This will be an important step and an important aspect going forward. We need to ensure that the operation and maintenance are being sustained going forward, also in the medium and in the long term, so that people can really benefit from the project and from the omni-processor installation in the Cox's Bazar site. And obviously this is particularly relevant in terms of energy requirements. Yeah, we all know that the omni-processor has certain energy requirements, and we have to ensure that the operation and maintenance costs are being adequately addressed and being considered either by taxes, tariffs, or transfers by the government. So I really have to say that I enjoyed the session today. Again, thanks to everyone for joining, for your active participation. And actually, I'm looking forward to the next Circular Economy webinar, so the series number 9, and I hope that this will happen soon. So with this, I would like to close for today. I wish you a great day ahead, and please stay connected with ADB on social media and join also our next upcoming webinars and sessions. Thank you.
Thank you, Christian. Thank you, everyone. Have a good day.
Have a good day.
Thank you.
Thank you.
Yeah, thank you, everyone.
Thank you. Thank you.
Thank you.